Welcome back. Today we're looking at volume of cubes and cuboids. Okay, before we start, we've got another starter here. Put a bit of a timer on for 10 minutes. Can you answer all the questions within 10 minutes? Whatever you've done after that 10 minutes, just stop, have a look at the solutions. So pause the video now, have a go at the starter. Okay, so I'm going to go through the answers here. First one, nice and easy, 0.405 times by 10, where all the numbers shift up one place, so you should get 4.05. There's your first answer. Second one here, we've got a bus shelter method, so we're using division. How many 8s go into 5? Well, 0, and I've got remainder 5. So we're moving on then, we've got to do how many 8s go into 57? Well, I know 7 8s are 56, so 56 fits in, 8 times 7, and we have one remainder. How many 8s go into 15? Well, 2 8s is 16, so that's a little bit too big, so just 1 8, and we've got 7 left over. How many 8s in 72? Well, that's 9. And so our answer there is 719. Next question. A farmer has a field that is 200 metres long. Just going to do a little diagram. And 16 metres high. Work out the area of the field. So it's a nice rectangle. How do we work out the area of the rectangle? Base times by height, 200 times by 60, which should give us an answer of 12,000 metres squared. Really well done if you got that one. Work out the perimeter. Well, remember the perimeter is all the way around the outside. So let's just say if I started at this point, I walked along that part there, I've walked along 200 metres. I then walk up this bit here, an extra 60 metres. This side here, that's 200 metres, so I've got to add that on. And I've got to go back to where I started, I've got to add another 60. So that would be the total perimeter, which is going to be a total of 520, and that's going to be metres because it's a length, so our unit is just metres. Brilliant. Last question. A bottle of cola holds 3 litres. How many 120 millilitre glasses can be poured from one bottle? Well, my issue here is I've got 3 litres and 120 millilitres. So they're two different units of measurement. So if I can change one to the other, hopefully it will make it a little bit easier. So I'm going to change litres into millilitres. Well, there's 1,000 millilitres in a litre. So if 1 litre is 1,000 millilitres, 3 litres is going to be 3,000 millilitres. So in order to find how many 120s fit into 3,000, I've got to do 3,000 divided by 120. And you can use a calculator for this one. We should get an answer of 25. So you can fill 25 glasses from that 1 3-litre bottle. So what is volume? Well, if I wanted to fill that cuboid completely, I'd need to know its total volume. So the amount of space an object takes up is what the volume is. Have a look at this cuboid here below. We could find the volume of this by counting the number of cubes that is made up of. So if we start counting here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. But that's not all. We've got that other layer back here as well, don't we? So we've got 15 there and 15 on the other side. But that would take a long time to keep adding up all the cubes. So we want a formula to be able to work out the volume. So if I had to continued adding all of those up, I would have got 30 cubes. But we don't want to waste time adding all those up, so let's use that formula. The volume of a cube equals the width times height times the length. We can also call width base, so we could have the base times by the height times by the length. So we've just got that extra bit there. So like with area, we did base going across the bottom times by the height. We then just have to times it by one more thing, which is the length that it goes backwards to find that solid volume. Getting stuck in straight away, let's find the volume of this cuboid here on the left. Well, let's remember the volume of a cuboid equals the base times by the height times by the length. We could shorten that by putting base times height times length like that. And now let's fill in the right bit. Base is 6. Height, it goes up by 2 centimeters, and the length is how far it goes back, which is 3. 6 times 2 times by 3, 36 centimeters. And just notice the units here, centimeters cubed. Look in the formula, we've got 3 things times together, so we've got centimeters to the power of 3, centimeters cubed. You've got a chance to have a go at a question here. Pause your video, have a go at that, and then we'll go through the answer together. Okay, let's have a look at the answer. Volume equals the base times the height times the length. So let's write out the formula. And now let's plug in those right values. So we know that the base is 5, the height is 2, and the length that it goes backwards is 4. 5 times 2 is 10, times by 4 is 40. Let's not forget the units. Centimeters cubed. Well done if you've got that one. On the next slide, you're going to have a few questions like this. So choose how confident you are. You're going to find the volume of each of the shapes. So this is your bronze questions, the red ones, silver questions, yellow ones, and gold for green. If you do go for the gold questions, I've just got a little example one here to help you out. You're told this in these questions, the volume is 40 centimeters cubed, and you need to find out what x is. So let's remember volume equals base times by height times by the length. Let's fill in those values. The base is x. Don't worry that it's an x at the minute, just keep going on. The height is 2 and the length is 4. So putting these together, 2 times 4 is 8, so we've got x times 8. Remember, x times 8 is the same as 8x. Well, 8x is the volume, but the volume is also 40 centimeters cubed. So if I've got 8x, that's got to equal 40 centimeters. Remember 8x is 8 times x, so what does that x need to be in order to make it 40? 8 times what gives me 40? 8 times 5 gives me 40, so that x needs to be 5 in order for this volume to be 40. So you're going to either start on the red if you're not so confident, yellow if you're feeling quite confident, and if you start yellow, finding it quite easy, you're then going to have a go at those green questions, which I've just given an example to. Pause the video here and give yourself 10 minutes to answer the questions you decide. Here are your answers, so again, pause the video and just mark off the ones that you did. In your exam, you're more likely to be given a question which is a little bit more worded, a little less straightforward. Let's have a look at this one together. A small fish tank has 15,000 centimeters cubed of water. Remember, centimeters cubed we know is volume, so that's a nice little indicator to tell me that I'm looking at volume. The length of the fish tank is 50 centimeters and the width is 10 centimeters. They've nicely labelled that for us. What is the depth of the water? So remember, depth is how deep it is. we want to work out this value here. I'm going to call it x. What's the depth? Pause the video now and have a go at it. We'll then go through the answer together. Okay, well done for giving that one a go. So I know that the volume equals 15,000 centimetres cubed. It's told me that in the question at that top bit there. I also know volume equals base times height times by the length. What is the base, the height and the length? Let's have a look. The base is 50. The height is what we don't know. We're going to put that as x. And the length is 10, how far back it goes. 50 times x times 10, well that's going to give me 50 times 10 is 500. 500 times by x, that's going to be whatever the volume is. In the question it does tell me what the volume has to equal. So I need to find out what does that x need to be in order to find out 500 times x equal 15,000. What does that x need to be so that 500 times x is equal to 15,000? Well, you could either just use it through observation or you could use a bit of algebra. I want to aim to get x equals. How am I going to get there? I need to get rid of this purple bit here. It's timesing by 500, so I've got to divide by 500. And if I do it to one side, I have to do it to the other. You can use a calculator, so 15,000 divided by 500 is what you should put in the calculator, and you get 30. Is 30 a good enough answer? Well, let's make it even better. Let's give the units. Well, that's 30 centimetres. However, let's have a look. What's the depth of water in metres? So we do need to read the question and make sure we're giving it what we want. I need to change 30 centimetres into metres. How do I do that? Well, 100 centimetres equals 1 metre. Therefore, I've got to divide by 100. So I should get 0.3. It's a little bit sneaky at the end there, asking for metres. Just make sure you read the whole question. Okay, so we're going to combine a few things we've done together. When we were looking at area of trapeziums, of triangles, of rectangles, we then moved on to compound shapes, which was a shape made up of more than one shape. We can do the same with volume. So here we don't know how to work out the volume of a T-shaped shape, but we can split it up into different solids to help us work it out. So let's have a look. I'm going to split that shape into those three bits there, A, B and C. And if I work out each one of them, I can then add up the total volume and I've found the volume of the whole shape. Okay, let's have a look at A. Well, this height is 2 and the depth is also 2. I'm looking at this right hand side and applying it to the left. So to find the volume of A, remember it's base times height times length. The base is 3, the height is 2, the length is 2. 3 times 2 is 6, times by 2 again, 12 centimetres cubed. Okay, what about shape B, the solid B? Well, again, it's a cuboid, so volume of B is also going to be base times height times length, but what are those values? The base, what is this length base here? It's 10 centimetres. Let's have a look at the top. It's going to be the same as the top as the bottom. The height is from the bottom of the shape here all the way up to the top. What is that length there? Well, from here to here is 4, but I need to get all the way to the top of the shape, so I need to add 4 plus that 2 as well. So the height in total is actually 6. The length of B is how far back it goes, which is 2. So I can times all those together. 10 times 6 is 60, times 2 is 120, and that's also centimetres cubed. Last shape is the C, that's solid there. It's also a cuboid, so we've got base times height times length. The base is 3, the height is 2, the length is 2, so the same as A actually. We've got 3 times 2 times 2 gives me 12 centimetres cubed. I found the volume of A, B and C separately, so the total volume will be all of those added together. 12, add 120, add 12, will give me 144, don't forget the units, centimetres cubed. So I've given you an example on the previous page. Can you use the same sort of method to find the volume of this shape? So remember, you're going to cut the shape into 1 or 2 or more shapes, find the volume of each and then add them together. If you do that quite easily, can you remember how to do the surface area? Pause this video, have a go, and then play it once you are ready. Here are the answers that you should have got, so just mark them off. Okay, so your turn now. You've got a few questions to answer. Pause the video, have a go at these 4 questions, and then play the video once again when you're ready. Here are the answers. So again, mark your answers that you've done. Try and spot where you've gone wrong if you didn't quite get the right answer. Give yourself bonus marks for including those units. They are important. Okay, let's finish with a challenge question. A cuboid of milk has a base 8 by 8 and is 20 centimetres in height. I pour 400 centimetres cubed of milk out into a glass. What is the height of the milk left in the carton? Pause the video, have a go at this. I would recommend drawing out a picture and finding out what you know. So we've been doing volume, so start off by finding the volume of the whole thing. Then think about how pouring out 400 centimetres cubed is going to change the height of the milk. Okay, so we're going to now go through the solution to this question. At any point, if you feel like the answer has sort of sparked something and you now know how to do it, pause it and finish off the question at any point. If not, just have a look through the solution. Okay, so I suggested it might be helpful to sort of draw a diagram. So we've been doing cuboids, so I'm just going to draw a nice little milk carton and I'm going to label the sides I know. So it tells me the base, so that's that bottom part here, is 8 by 8 and the height is 20 centimetres. So there's my milk carton. And she pours 400 centimetres out. What is the height of the milk left in the carton? Well, I think the first step I need to do is finding the volume of the milk before anything was poured out. So before any pouring. And we do that just by base times height times length, like we've done for the whole lesson. Base times height, so the base is 8, the height is 20, and the length it goes back is 8. So timesing all those things together, 8 times 20 times 8, we should get 1,280, and that's centimetres cubed. So that's how much a full carton can hold. But if we look at the question, she pours out 400 centimetres cubed. So when the carton's full, it's 1,280, but she pours out 400, so I've got to take away 400 from that full carton. That leaves me with 880 centimetres cubed left in the carton. And I need to find out the height. Or how am I going to do that? Let's have a look at this, our milk carton again. The height is no longer 20 centimetres because the milk started off at the top, but 400 has now come out. Let's say that's there, and we've got this new height. I'm going to call it X because I don't know what it is. I'm going to draw that over here. Oops, let's just get rid of that line. Okay. So our milk carton started off full, but it's now at this height here. We don't know what that height is, and that's what we need to work out. So we need to work out what that height is there. The base of the milk carton and the length that it goes back is still the same though. Those two things haven't changed. We know that this volume of milk that's left over is 880. At full it was 1280. We got rid of 400. So what's left in that carton when it's slightly less full is 880. So we know the volume is 880. We also know the volume is base times height times length. So we know that 8 times by the height times by 8 has to equal that 880, and that's how we're going to find out h. 8 times 8 on this side is 64. 64 times the height has got to equal 880. So what is h? 64 times what is going to give me h? Well, I can't do that in my head. So I'm going to try and get h on its own. I want h equals. Again, we're looking at algebra. How does that line here differ from that line there? Well, this one means 64 times, and this here is just h on its own. So I need to get rid of 64 times, or times by 64. So we do the opposite, divide by 64, and I do that on both sides. So the height is going to be whatever 880 is divided by 64. Put that in my calculator. I get 13.75. That's going to be centimetres because it's this height here. Does that seem about right? Well, yeah, it started off as 20 centimetres. We poured some out, so it's going to be less. 13.75 sounds about right. Really, really well done. That's a really tricky question and probably would have been near the end of an exam paper. That marks the end of the lesson, so well done for completing today.